Hello there, viewer. So today I'm here to demonstrate an extremely impractical but very entertaining Enderporter system. So the idea of this system is that you enter in the location you want to go with some binary code with these 8 levers here, and then that code is sent along with you as you travel through the system. And so instead of having to choose where you want to go at every stage or navigate to some place, you simply enter the code once, and then as you are teleported each station sends you to the next one that you need to get to. So to make this make more sense, I'm going to demonstrate. So each station has a unique code. This station is the one in the very center in my case. So this station has the code 11. You can ignore the 1 at the end. This station basically has the code 1. And currently I only have 7 stations just because the setting up the connections is a bit of a pain in the ass. So I'm going to go to station 111. Technically 1111, 4 ones, but one of the ones is required for the system to work properly, so it doesn't really count. So there's my 4 ones. So I enter them in with these levers here. The lever being down, or the piston being down, means it's going to be a 1. The piston being up means a 0. And then I'm going to press the button. So at this point there's going to be a little bit of a delay. Then I'm teleported up here. I have to replace the ender pearl. Once I've replaced the ender pearl, I can press this button. I don't need to wait that long, by the way. And the signal will be sent off, I believe, to over there. Should see in a moment here. I will be teleported. I'm teleported to the next station. This time I'll do it much faster. Just do this, do that. Alright, let's wait for the next one. Should see here I'm teleported, and I believe this is the final station, but it's always just good practice to do this and press the button, because you don't actually necessarily know, and it also resets the system when you press this button. You can see I wasn't teleported, and I don't know if you noticed in the bottom left of the screen here, but this lamp that says exact match was on, just to indicate that we successfully found the station with the code 1111, and then a bunch of zeros after it. So yeah, that's how the system works. Just for fun, let's go to the farthest away station from this one. So the farthest away station should be 001. If I've done math right in my head. So we should see when I press this. So we're going to teleport it. I'm going to replace it. That's weird. For some reason I could go way farther that time. Anyway, press that. Press this. Waiting. Signal being sent back to there. So now I'm being sent to the parent node. I'll explain how this works a little bit more in a second, but I thought more fun to just demonstrate at first. So about each of these is a 450 blocks away from each other. And that's possible because I'm on render distance of 32 right now. So this definitely gets less effective if you're on a server that has lower render distance, for example, or if your computer isn't able to handle the higher render distances, because the range that these ender pearls can be triggered is dependent on your render distance. So if you have 32 chunk render distance, you can place your stations as few as oh, am I here? Maybe there's an ender pearl missing. I might have messed one up. Yeah, I should have gone over here. Let's go check if the ender pearl was missing. I might have just forgotten to replace it. Anywho, yeah, depending on your render distance, you will get different mileage out of this. So let's just quickly check if the ender pearl was missing. Maybe something's broken. I don't know. We're gonna find out very soon. The lines are just because I'm using the structure blocks. I don't know. Maybe one of my lines is there are these repeaters that are like 15 redstone apart, so I probably just have one that's 16 redstone apart accidentally. Anyway, I believe I've demonstrated my point well enough. So I'm going to go back to, actually let's just go faster. I'm going to go back to spawn here. Okay, so that's the interesting part of the video done. And now I'll talk a little bit about how this works. So basically the way that it works is you have 3 components to this like chunk of stuff. Actually, let's use this one because it's isolated. There's 3 components. The first component is pretty small. It's over here, the gray stuff here, and this is, I'd call this the encoder. You give it a binary like sequence 111 0 0 0 0 0, right? Then you press this button and it uses the timings of hoppers to send each of those signals one after the other. So 0 meaning a lack of a signal, 1 1 1, no signal, no signal, no signal, no signal, no signal. And then the receiving end of this, which in this case just it seems kind of silly because I'm entering it in here then immediately decoding it, but that's so that the same system can be used to decode signals from other stations. Anyway, the decoding side, what you do is you have, when you receive the first signal, so you must always receive a 1 at the beginning. The 1 triggers an item to be pushed into this dropper, and then I simply have and then also it triggers an item to be put into this hopper. So as the item goes along in the hopper like this, it triggers the comparators one after another, progressing an item forward in these droppers. And what that does for me is it allows me to isolate a signal. So the signal that has been sent from the other stations is sent along this orange line here, and you can see it's going into all of these droppers. These droppers are called RS NOR latches. So it just means that once you send them a signal over here, they output a signal over here until you undo it. Anyway, point is, it's just triggering all of them at once because that's the easiest way to do it. And then I have pistons that push down a block so that the signal actually travels through and triggers the RS NOR latch. So that's how I go from a signal that's, being timed out as a 1 and then a 0, then a 1, to just kind of stored as 9 different pieces of information in these hoppers. And then this part isn't that important. Basically, this plays back the signal once the person presses. Basically, this records the signal that was received, and then when this button is pressed, it plays it back. And then this final part here looks complicated, but it's just because it looks large. So what's happening here is we need to determine which situation we're in. So this structure, the structure of this system is a tree, which is a programming term. Basically just means that you have, at each point in your system, you connect to 3 other points. One that's known as your parent, so you go up to them is kind of the term that we use, and you have 2 children, a left child and a right child. And so when you receive a signal, you're able to know whether you're supposed to go to your parent, your left child, or your right child by using this logic. And I'm not going to go into it because it's boring, but it's basically just if the place you want to go is doesn't match at all the area you're in, it goes up. If the place you want to go is where you are, you're done. That's what this lamp is for. And if the place you want to go is similar to the location of this particular node, it then determines from the location if it should go left or right, and then sends that signal along on its way. So yeah, those are the 3 parts of the circuit. And as far as using this goes, there are 7-8 schematics here, and they basically just represent the length of the code. So by that I mean you can have a code of length 1. So you can see we have the mandatory 1 at the beginning, and then we have a 1, and the rest are zeros. So codes must always begin with a 1 and end with a 1. So this is, maybe you call this of length 0, right? There's nothing in the middle of these 2 1s, right? And then I'm blind. Over here we can see a code of length 2. So you can see, or of length 1, I guess. See there's a 1, then something in the middle, then another 1, and just continuing onward and onward here. We have this same thing, and I think you can see where this is going. Basically a gap between those 2 1s increases. And it turns out that the logic for handling each of those cases is actually a little bit different. Not substantially so. It just involves changing the position of this green line and changing the position of this little clump of redstone. But it's not that big of a deal, but it's just nice to have them as schematics, because once you've done that, getting to all the other combinations is very easy. So just for demonstration purposes, if I wanted to change this code from 1001 to 1111, I would go along here putting redstone torches. So for example, right here is a 1, this is a 0 currently because there's no torch, a 0 and then a 1. So I would delete these 2 redstone, place them with 2 torches, then I'd go up top here, delete these 2 redstone, replace them with 2 torches. And that's it. That's all that you have to do. So the setup of each station, building these stations isn't necessarily the easiest of tasks, but it also isn't ridiculously hard. They're very repetitive, very tileable, kind of. I mean, yeah, this actually is fully tileable, so if you wanted to make this, you know, longer signals, so you could have a greater number of base stations of like nodes you can go to, that's totally possible. Anyway, yeah, I think that basically showcases this strange little invention. I would say that it's very fast to travel. However, I have noticed some oddities with ender pearls disappearing. I don't think my stasis chamber here is perfect. I'll have to like watch maybe an etho video or something to see how to do that. And then the other clear downside is that you're limited to loaded chunks for when you want to teleport. So you have to make sure all of your stations are within your render distance at all times, or the 2 stations that you could go to, right? Every station is connects to 2 other stations, so both of those stations must be within render distance. So in my case, it gives me about a 450 block range around each station that I can go out, and that's quite a lot. I mean, you know, it took me 30 seconds to travel through 3 or 4 stations, which would have been you know, 1600 blocks total. So I traveled 1600 blocks in, you know, 20 seconds, 30 seconds, probably less, probably 20. That's pretty fast, I think. But then, you know, the downside is putting this entire system at every single node, which is why I think it's more entertaining than anything else. Well, hope you enjoyed that. Bye-bye.